And here we are in another video where we are going to be simplifying expressions that are a little more challenging involving exponents. And in this one in particular, I've grouped a ton of things with fractions and raised them to a power. Oh yeah, let's dive into it. So this first one, not so bad. I figured, you know what, let's start out with an easier product, but with a lot of exponents going on. Handle it piece by piece. There's not much we can simplify in here, but we could simplify in here that x to the 0. So let's do it. So I have 2x to the third. So everything gets raised to the third power. That's 2 cubed, and that's x to the third, which is 3 times 3, which is 9. Remember, when you raise a power to a power, you multiply those exponents. And then we're going to multiply that by, now check this out. This is really, x to the 0 is really just 1. So this simplifies down now to just 3 to the negative 2, because x to the 0 went to 1. And we'll go piece by piece. So the x to the 9th can't really be simplified, but 2 to the 3rd is 8 times x to the 9th times 3 to the negative 2, which ends up in the denominator as 3 to the 2. So we go on from there and we get 8x to the 9th all over 3 squared, which is 9. So you go piece by piece and you're okay. If you're having trouble with any of the rules I'm using though, watch my earlier videos in Chapter 8 in Algebra 1 so that you understand why I'm doing the processes I'm doing. Okay, let's check out B. B is a juggernaut. But as I've said in previous videos, if you can simplify what's inside the parentheses first, do it. It makes life easier. So here, negative 4 sevenths can't not do anything with. So I've got negative 4 over 7. Right, so we have that. Then we've got x over x to the 5th. Well, let's kind of put that off to the side. X over x to the 5th. Well, that's x to the 1 over x to the 5. So you subtract the exponents because you're dividing. 1 minus 5 is x to the negative 4. With the negative exponent, that means the x will end up in the denominator. So you get x to the 4th in the denominator from all of that. A little bit of side work. Let's do the same with the y's. You get y to the negative 5th all over y squared. Well, you would subtract exponents. Negative 5 minus 2 is y to the negative 7. And so again, a negative exponent, so the y ends up in the denominator. So you get y to the 7th. And then we have m to the negative 1 in the denominator, so that ends up in the numerator as m to the 1. And remember, we still haven't raised anything to the negative 2. So here's the good news. We've simplified the inside. Now let's work on this outside part. The negative exponent's there, so everything gets flipped. Every bit of this, that big fraction, we have the reciprocal now. So you have 7x to the 4th, y to the 7th, all over negative 4m. Now just to the second power because the negative's been applied. And now everything gets squared. What's 7 squared? Well, it's 49. 7 times 7. X to the 4th to the 2nd, we're raising a power to a power, so we multiply. 2 times 4 is 8. That's x to the 8th. 2 times the 7, y to the 7th squared, is y to the 14th. All over. Negative 4 squared. Negative 4 times negative 4 is positive 16. And then m to the 2nd is m squared. That's it. It's a lot, but you go piece by piece and you simplify the inside first and it becomes better. That's a difficult one because you really have to discipline yourself to take your time. Now letter C, I threw you a curveball. There's a lot you could simplify on the inside, but look at this. Everything on the inside is being raised to the 0. And what's anything raised to the 0? 1. So all of that, if you notice that first, everything in the parentheses becomes 1. The negative is not being raised to the 0, so it does not become 1. The opposite of 1 is negative 1. That's awesome. I love that problem. Love it. And finally, we have one more problem where we're raising everything to the second power. I actually think D is a little easier than B. We're again going to simplify everything inside the parentheses first, and then we'll raise everything to the second power. Notice you have 2 over 6. You are not subtracting. Please promise me you won't subtract. Please. Don't do it. You are dividing 2 by 6. So 2 over 6, take that off to the side here, is equal to 1/3, dividing the numerator and denominator by 2. So on the inside, we end up with 1 over 3. X to the 5th over x to the minus 1. Take that off to the side. Well, we would be subtracting exponents. 5 minus -1 is a positive 6. So that ends up in the numerator. I almost called it the numerator. And then you have z over z to the 4th. We'll do this over here. Well, that's z to the 1 over z to the 4th. 1 minus 4 is -3. So that's z to the -3, which means it ends up in the denominator. Nice. So we've now simplified the interior. Now let's raise everything to the power of 2. So if I raise it all to the power of 2, let's think about this. Everything gets squared. Every exponent gets multiplied by 2. 1 squared, or 1 to the 2nd power, is 1. So that's just going to be 1 in the numerator. X to the 6th to the 2nd is 2 times 6, which is 12. X to the 12th. The denominator would be 3 squared. Right, 3 to the 2nd, and then z to the 3rd squared is z to the 3 times 2 is 6. Now all we do is just put everything together and we're in good shape. 1 times anything right up here is itself, all over. 3 squared is 9, you got it. And then z to the 6th is just z to the 6th. So the moral of the story here, guys, again, take it piece by piece. If you've got a fraction, see if you can simplify on the inside first, unless you have something raised to the 0. Be patient, folks. Gotta practice this stuff. Might even need to rewind it and see how I went step by step. When you approach one of these problems frantically, going too fast, and don't go piece by piece, that's when they become difficult. When you patiently use the order of operations and go piece by piece and take your time with side work like this, you'll be in great shape. And after a while, that side work will become mental side work. See you next time.